Uh, my name is Advice. Today I'm going to talk about the line shaft. This stuff is just for N6 Mecano, and then we are going to do topic 2. I just did the introduction of the line shaft in the other video. I just talk about the introduction and all the stuff. This is just an example 2. Example 1 we are done with it, and then the example 2 says just the layout of the line shaft is shown in figure 4.1. This is the figure 4.1. This is what we are talking about, and they say determine the reaction on the bearing. Now we are going to look for the reaction on the bearing. These are the bearing and this is the gear and the pull. So they want the values here. So when we are dealing with this one, it means we are going to use the formula that says sum of clockwise moment equal to sum of anti-clockwise moment. The law of moment. Alright. So here we are going to take the moment about R1. This is the R1. We are taking moment from R1 to the R2. Therefore, sum of clockwise moment equal to sum of anti-clockwise moment. Therefore, here, like I can copy this one like a clockwise moment to sum of anti-clockwise moment. Alright, here I'm going to put the forces that are going to rotate in clockwise and the forces that are going to rotate in anti-clockwise. Here, when we talk about clockwise and anti-clockwise, when these things will take moment about this one, it means this thing must rotate. The forces must rotate. You know, like for example, this one, if here is the point of fulcrum, it means it will just rotate like this. Like even this one will rotate like this. This one, because it's pulling in that way, it means it will rotate like this. So therefore, these two are rotating in clockwise, and then this one in anti-clockwise. Is how we are going to put the values there. The first one is there. We take the moment from there. R, don't forget. It means if we want to put this force, we multiply with this one. It's the same as torque, because torque is distance multiplied by the force. Therefore, we are going to take our first is 20, which is here 200 multiplied by, here we are going to calculate it not in millimeter, in meters. 0.3. We say plus because we are done with this one. We are done with here. We are coming to the pull. The amount of the pull is this one. Therefore, this is the weight of the gear 200. This one is the weight of the pull 450. Therefore, we are going to 450 because these two are going in the same direction, which is clockwise. We are going to say 450 multiplied by. Now we'll count the distance from here to here. If we count this one is 300 multiplied by 600, which is 900. We'll convert it to 0.9 millimeter, and then we are done with the clockwise, and then we are coming for anti-clockwise. We say equal to anti-clockwise is R2. R2 is our force, which is unknown, multiplied by the distance from here to here is going to be 1.1, 1100, which is going to be, we'll convert it to, there is in millimeter, we'll convert it to meters, we're going to say 1.1. Therefore, now we do the calculations. We'll do the this one multiplied by this one is 60 plus this one is 405, this one, and then we say 1,1 R2. Therefore, we add this one and divide it. When we add it, is going to be 465 equal to 1.1 R2. When we divide it, it's going to be R2 equal to 423 newtons. We're done with the R1. So here we're going to R2. Now we take moment. Take moment about R2. When we take moment about R2, it means we are counting from here to that side. The first one, when we are starting from here, is the pull. Sum of clockwise is still the same, even though I don't write it, but I will write it for understanding. Alright, anti-clockwise. When we are standing here, can rub these arrows now that are not going to be the same. Alright, when I'm standing in, this is just a point of the reference. It means this thing is going to rotate in the direction, like this one, they have to turn from this point that I'm taking the moment about. Like for this one, is going to turn like this. Even this force is going to turn like this. This point doesn't move, but this one, because it's pulling upward, is going to turn like this. So therefore, this is clockwise direction, and these two are anti-clockwise direction. Therefore, we say R1 for the clockwise, R1 multiplied by the distance. We add this distance because we are counting from here to here. We say 300 plus 600 plus 200, which is going to be 1.1. We convert it to 1.1. Alright. Therefore, this is equal to these two that is moving in anti-clockwise. The first one is from here to here is 450 multiplied by the distance. The distance is 200 millimeter. We convert it to meter, which is to 0.2 meter. We add, and then the second one is 200 for the gear multiplied by the distance. We add these two distance, 600 plus 200, which is 800, is going to be 0.8. And then we say 1,1 R1 equals to this one. And then my calculate says this is equals to 90 plus 160. This 90, this 160, and then we add. When we add these two, we are going to get, let's just go fast in this one. If we add these two and then we divide, let me put it in the simple way. We divide by 1.1 and then we divide by 1.1. We are going to get R1, which is going to be equal to 227.3. 227.3. This is what they asked one about the R1 and R2, which are the bearings. Thank you.